Hey Tone, let's take a look at this one. Order of operations is in play, friend, because we're dealing with an expression here, so we're just going to simplify this up. Now, as I look through, yes, we have exponents in here, but these are variables, so there's nothing we can really do right now. Of course, we could flip them. I always wait to flip them right at the end, because if you flip them early, it just makes a big bunch of fractions, and a lot of the times, especially if you're going to multiply two negatives, they'll cancel out anyway and become positive. So I always flip them right at the end. Over here, though, we have this term right here, 2x raised to the negative 3. So let's go ahead and evaluate that. I'll copy over this here. Y is by itself. Remember, y is like a 1. You can write that in if you want. Now over here, we're going to have, this is going to simplify to 2 to the negative 3, x to the negative 3. And again, like, I'm not going down the rabbit hole yet of flipping this over or anything like that, right? And over here, this is really like an exponent 2 to the 1. So really we can just see this as using, a bunch of exponent properties over and over and over again, right? I'll highlight that one yellow. I'll highlight this one green. We have our x's. Get out of the way screen. And then we have y and z, right? Which don't really need to be highlighted. So let's take a look at that one. Same base, we're multiplying, which means we add the exponents. So this is going to equal or simplify to 2 to the negative 2. Right there, we're just adding her up. X's, we have negative 9 plus negative 3, so that's going to be negative 12. We have y to the 1, and you can write the 1 in if you want. We have z to the negative 2. Don't write the 1 on the streets, by the way. People make fun of you on the streets, but between you and me, we're safe. Here's how I like to think of this now. This is really all one great big fraction over 1, right? So we can take things, anything that's negative, and it's going to get flipped down. So this 2 to the negative is going down, the x is going down, the y can stay by itself, and the z is going down. So what that's going to leave us, we just have y in the numerator. Downstairs I have 2 squared. I have x to the 12. I have z to the 2. Remember, when we flip an exponent, it's just the sign that changes. If this was a negative 2, it would still be a negative 2 down here, the base, I mean, but the exponent is what flips. After that, we can just take a moment. 2 squared is 4, so we should be classy about that, and we'll evaluate that right there. Hello, blue. There we go. So there we go, buddy. That's it. See everything as one big fraction. Do all your exponent properties first, then flip any negatives that are still there. And, even if you had a negative exponent down here and you flipped it up, it would become positive. So it's the act of flipping that changes the sign on the exponent. Hope that gives you a new way to think about it. Let me know how you make out.